view a construction, I'll review them. Remember, all constructions are up on Aspen under transformations. All right, so I appreciate it right now if you listen to me and not try to do some of the review work. All right, you'll have time at the end here to try some of it out. Tonight, you can try some of it out. All right, I'm not checking tomorrow. All right, reflections. I want to go through all the different lines I'm going to ask you possibly to reflect over. All right, here we go. Start listing them out for me. What are the different lines I could ask you to reflect over? X and Y axis. Other lines we've reflected over. Okay, Y equals a number. I'm just going to put a number here that's not hashtag. All right. X equals a number. Y equals a number. What type of line? Let's review everything. Y equals a number. Horizontal. X equals. Vertical. What other lines? Thomas? Y equals X. We'll do this right now. What's the rule for Y equals X? Flip, flip, flip coordinates. If I ask for Y equals X, you're darn right I'm probably going to ask for Y equals negative X. And what's the rule for that? Flip and switch signs. Yep. I believe we've done that in here. Right? And that was a half a day we did in here, right? Use the slope to reflect through the point. Yep. Everyone good on those lines? Do you want to ask anything on those lines? Point reflection. All right, Billy, sorry. What do you got, stud?
The one where it's X equals Y equals negative X.
Correct.
Switch the signs. Is that when it's like?
Go ahead. Give me a pair. Give me a coordinate you're thinking about.
2, 3.
2, 3. If I want to reflect over Y equals negative X, switch them. Change the signs. All right. Anything else going? All right, point. Any questions on point? I'll do if you want, we can do an example. What do you got? Sure, just for you. Well, first of all, so I don't have to make one up, is there any? Oh, yeah, there you go, everybody. Number 16. That point happens to be the origin. All right, here we go. I got -3, -1. I'm going to reflect it through the origin. So we use our slope. Over and up, how many to get to the origin? Over 1, 2, 3, up 1. Match that distance on the other side. 1, 2, 3, up 1. Here is my reflected point. And that point is 1, 2, 3, 3, 1. And Mason, if it's the origin or if it's any random point, same thing. Over and up, how many? Over and up. All right, on the other side. All good there. Anything else on point? Yes.
Just a vocabulary. When it undergoes a reflection in the y-axis.
Over the y-axis, yep. Anything else? And finally, under reflections, I could give you 2 triangles. What line did I reflect over? Okay, what line did I reflect over? Find the line of reflection. Guys, all good there? Translations. What do I mean by function? Anybody want to give me an example of a function notation for translations? Fiona. You're darn right. So I'll go -4 + 2 here. This is function notation. All right, then we have vector notation. How would you write this function notation in vector notation? Go ahead, translation stud here. Negative 4, 2. And then again, I could give you two figures. What's the rule? Okay, what's the rule? And I may have you write it either way. Just throwing that out there. Any questions there? Rotations. We comfortable doing 90, 180, 270, clockwise, counterclockwise? If you want to go over an example, we can. It's up to you. Turn your paper or memorize the. Do we want to go over the rules for you guys that memorize the rules? Sure, I'll do it. No problem. You guys that want to turn your paper, you keep turning your paper. Rotation of 90. XY becomes negative YX. Rotation of 180. XY becomes negative X, negative Y. I just changed the signs. And then finally 270. XY becomes Y negative X. Okay, if you want to remember the rotation rules, there they are. What if I rotate in a negative 90 direction? Same as 270. If I rotate negative 270, same as the 90. Okay. All good? And then dilations, I didn't put anything under there because we did them yesterday. Everyone's all right with dilations? Compositions, how do we, here you go, compositions. Is it all right if I get rid of this? Everyone's all right if I get rid of so I can write some more stuff here? Let's say I do this. Rotation of 90, I got that little symbol there, reflection through the y-axis. Which one do I do first? Read them right to left. So you're going to reflect first, rotate second. All right. So make sure we read those, perform them correctly, right to left. Symmetry. What's points? I know what you guys know what line is. You draw the line down, it flips over. What's point symmetry? What's up, Billy? How can you tell? I plop a figure on your table right now and say, does it have point symmetry? What are you going to do? How many degrees, though? It's got to be a certain amount of degrees you rotate it around. Here you go. Ready? Does the letter E have point symmetry? Why not? Can't turn it on its side. It's got to be how many degrees? 180. So turn it upside down. Is it the same E?
No. It'll be backwards.
Thank you. Does X have point symmetry? Yes, it does. Okay, yes, it does. Rotational, I got a little example for you guys here. A regular pentagon. There it is. A regular pentagon. Does that have rotational symmetry? Imagine all the sides are equal up there. Can I turn it 180 or less and get that same pentagon back? Yes, it does. All right, so and I know it's been a while since we've talked about these words. What's the magnitude, or excuse me, the order? How many times, if I turn this sucker 360, how many times would you see this pentagon back? How many different times? If I turned it 360 degrees, how many times would I see that pentagon? 5 times. So the order is 5. Magnitude. What's the smallest degree I can rotate it and get that pentagon back? Well, you told me what? From 360, you'd see it 5 times, right? 360 divided by 5. What's the smallest degree measure? 72 degrees. All right, 72 degrees. Let me throw in a little bonus for you right now. How many degrees does it take me to go from this vertice to that one? How many does it take to go from this one to this one? 72. And then another 72, it's going to take me 144. All right, so 72 every time. And finally, constructions. Anyone we want to go over now? I know they're up online, but it could be anything. I'm not going to give this one away, but I will tell you it'll be multiple ones. There'll be 2 on there. I'm not just going to tell you which 2. Actually, there might be 3. Actually, now that I say that, there might be 3. Can you reflect and find? So, hey, take a look. Quick look. Can you reflect a figure over a line? And then what if I give you 2 figures that have been reflected? Can you find the line using your compass and straight edge that I reflected over? Okay. Rotation. The only thing you got to worry about for rotation is how to find the center of rotation. Translation given a vector. Dilation given the scale factor. 3 of them on there. 3 of them. And I'm going to give back your quizzes after I'm done talking. So you can, because some of you guys, it was a translation question, but you reflected for some reason. So I don't know where the disconnect was. Thomas, what's up?
The quadrants of an axis, where do they start and what?
Top right-hand corner is 1, and then it works counterclockwise, just like you rotate. Yep. Emma, finding a line of reflection. I certainly will. I don't know how good it's going to be, because I don't know if, actually, we'll see. Now, this may not, I'm just going to advise everybody, this may not be the best. The process, obviously, will be fine, but. Okay. So I reflected these. Where's the line on this paper that I reflected through? You take a pre-image and an image point. So go ahead, which 2 do you want me to connect? Okay, C and C prime. I take my compass and I do the perpendicular bisector, just once. And then wherever that is, math tools, compass. So open this bad boy up. Go to the other side. Line up my good old straight edge and make sure you do a line, not a segment or array of reflection. Line of reflection. There it is. Okay. And it wouldn't matter if you went from B to B prime or A to A prime. That's still going to be the same line. Okay. Yep.
Can we just do reflection?
Over a line?
I have a question.
Oh, sure. Go ahead.
How far from the
More than halfway. Remember, more than halfway. Okay. Reflection, sure, real quick. Let's say I have that line and I want to reflect that triangle there over that line. Okay. B is not going anywhere, right? So I only have to reflect A and C. Okay. So what I'm going to do, take my compass. I'm going to put it on the point I'm reflecting, and my goal is to intersect this line twice. Because you need to get a perpendicular line first, and then go to each endpoint, make the arc, other endpoint, make the arc, draw it through. And when you reflect, what change? What's preserved? Distance. So the distance from A to this line is the same from that point to A prime. Right there. So that's where A prime is going to be. And then I do the same thing for C prime. Okay, so you make your perpendicular line from the point, copy the distances. Billy. Sure. I'm going to have to give you a vector to translate. So along that one. Okay, can we please discuss this right now? What's the vector telling you? The distance and direction it should go. Should this triangle be over here? Guys, it's not a reflection. All right, don't extend this line anymore. Don't touch the darn line, all right, with your straight edge. This triangle should be up here, this length, all right? So the first thing, measure your vector. Billy, what point you want me to translate first? Okay, so I measured my vector. I go to C. Shoot. Let's try that again. Doesn't make sense for me to make an arc right there. No, you know the triangle's going to go this way. So make sure your arc is over here. Good there, Billy. Now I go from C to the beginning of the arc. I measure that distance from C to, the beginning of the vector, sorry. I'm listening.
Can you do it the way where you just measure it and then you do all the arcs?
As long as you know what arc belongs to what vertice. And now I go from here to the top of the vector. Makes no sense for me to do anything over here. I know it's not going to be on the other side. I make these two intersect, and there's my boy C prime. And I do that for A, B, and A and B as well. All right. Whew, good questions here. Tired out here. Okay. I still have two more things, but can you go to your packet right now? Because I want you to eliminate, I think, 2 of the review problems. I don't want you to get freaked out and say, we never did this. This is going to be on there, because it won't be. I think it's 20. Yep, 29 and 30. You're not going to be responsible for the line of reflection if they're not across, vertically or horizontally across from each other. So 29 and 30, don't bother doing. Don't get freaked out. All right, 2 more things. 2 more, and then I'll let you go on your own. Prove 2 triangles are congruent using rigid motions. Remember that day? Remember? Undergoes a rotation of 180. Rotations are rigid motions that preserve distance and angle measure. Thus, henceforth, subsequently, the triangles are congruent. Okay? You do have practice with those in the back of your unit review. Okay, so you do have practice there. And finally, same versus opposite orientation. Anybody want to give me a transformation that keeps orientation the same? Rigid motions in particular. I don't know, I don't care if I'm spelling this right or not. And then a couple that do opposite orientation. What are ones that keep it the same? So if you go ABC in a clockwise direction, it will always be ABC in a clockwise direction. What are some I could do? Translation won't change the orientation. Are there any others? Rotation. And there's another one. Point reflections won't change it. All right, point reflection. If you reflect through the point, the orientation won't change. And then there are 2 that will change it. Not just a reflection, line reflection will. And then something else that contains a line reflection. Glide reflection. That'll change the order of the vertices. All right? Yes, Mason. Sure. Glide reflection. Let's say I have triangle ABC, and I'm going to flip it over the x-axis. So now it's going to look like this. to be a glide reflection, the slide has to be somewhere parallel to the x-axis. Okay? Whatever line you reflect over, you have to slide parallel to it to be a glide reflection. All right? Ask your dance buddy there. All right? Questions? He's the one that demonstrated. Anything else? I think that was a pretty solid review there with you for Friday's test. Anything you want? Go ahead. Who you got, John? Yep. You do 2 perpendicular bisectors. Yeah, so if I go back to that question that Emma asked about the line reflection, if I, let's say I rotated it instead, if I want to find the center of rotation, I do this, and I do another one and see where these 2 perpendicular bisectors meet. Yep. And again, you are not responsible to rotate a figure using your compass and straight edge. Just find the center of rotation. Any questions? All right. Go ahead. You can get going on that. You guys know the answers are in the back. If you need review on the constructions again, go under our transformation folder on Aspen. Last time we talked about transformations in here.